All right, folks, in this video, we're going to go over how do we take derivatives of exponential functions, okay? So first, let's talk about what exactly we mean by an exponential function, okay? So an exponential function has the form f of x is equal to b raised to the x power. So an exponential function is a function in which the exponent, the power, is variable. It changes over time, okay? Here, b represents the base of our exponential function, and the base has to be positive, meaning it has to be greater than 0, but it can't equal 1. All right, why is that? Because 1 to any power is 1. You're not exponential, you're then constant. And so really quickly, let's make sure we're set on the concept of an exponential function. Let's say we had two functions. F of x is x squared, and let's say we had g of x is 2 to the x. Okay? My question would be to you is, how many exponential functions do you see here? Meaning, do you have two, meaning both f and g are exponential? Do you have just one, either f or g is exponential, or do you have no exponential functions? Well, in this case, there's only one exponential function, and it's 2 to the x power, okay? This is an example of an exponential function, okay? The reason why x squared is not an exponential function is because that 2 is a constant there, right? In fact, we call x squared a quadratic function. All right. So in this particular section, though, we're going to only be considering functions of the form f of x equals e to the x power. Okay. E. All right. So the base e is called the natural base. All right. So e is an actual value. E is a constant, just like you know how pi, right, is an irrational number, like it's 3.14, it goes on forever. So e is something like that. E is 2.7 and some change. In fact, if you guys give me a second here, I'm going to try to pull up my calculator and show you exactly what e is. Okay. Okay. So what's e? To figure out e, if you're in your calculator, if you have an 84, if you hit second, ln, which is natural log, which is has a base of e. And if I want to take e and raise it to the first power, because I just want to figure out what's the value of e. All right, there you go. You see e is 2.71828. Goes on forever and ever and ever. Okay, so anytime we talk about e, we're not talking about a variable like we do with x. We're talking about an actual number. Okay? All right, so in this particular lecture, and in your homework, we're only going to be dealing with exponential functions that have a base of e. Okay? And so how do we take that derivative? Well, let's say our function is e raised to some power, which that power could be a function of x. Okay? Well, it turns out that the derivative of that is, so h prime of x will be, we take the derivative of the exponent. We take the derivative of the power on e, and then it multiplies e raised to the same power. Meaning, very important, when it comes to e, when it comes to derivatives of exponential functions, please note that the power does not change on e. So this is the first kind of derivative rule where we see that there's really no change in the function itself. Okay? All right, so what you do is you bring out the derivative of the power, and it multiplies e to the original power. All right, I want to do several examples in this video because I want to make sure you guys are pretty good. So here we go. For example, f of x is equal to e to the negative 5x power. All right, our job is to find the derivative. Okay, so here we go. So f prime of x will be, okay, we're going to take the derivative. We're going to take the derivative of a negative 5x. So the derivative of negative 5x is a negative 5, and it multiplies e to the exact same power. Notice the power on e did not change. And that, folks, is our derivative. It's just that straightforward. You bring down the derivative of the power, and it multiplies e to the original power. Okay? So I can't stress this enough. Where did the negative 5 come from? The negative 5 is the derivative This is the derivative of the power, which was a negative 5x. Okay? All right, next example. Suppose we have f of x equals e raised to the x squared plus 3x minus 1. So all of this, the x squared plus 3x minus 1, all of that is the exponent. All of that is the power. So how do we find the derivative of this function? Well, we're going to do the same thing. We're going to bring down the derivative of the exponent of the power. So what's the derivative of x squared plus 3x minus 1? Well, we know from our sum and difference rule. We know that the derivative of x squared is a 2x. The derivative of plus 3x is a plus 3. And the derivative of negative 1 is nothing, is 0. Okay? And then, I beg you guys, put this in parentheses, okay? For this answer to be correct, that has to be put in parentheses because that entire quantity now needs to multiply e raised to the original power. Okay? All right, this is the correct answer. Okay, if I get rid of my parentheses, now this becomes the incorrect answer because now only the 3 is being multiplied to the e. Whereas I need the entire 2x plus 3 multiplied to that. So the correct answer is 2x plus 3 times e to the x squared plus 3x minus 1. So I hope you guys are starting to see the pattern here. You just bring down the power, the derivative of the power, and it multiplies e to the original power. All right. What if there's a constant already out there? Okay, so suppose we have f of x equals 5 times e to the x squared. Okay, well, I think you guys have a good idea what's going to happen here. So the 5 is a constant multiple, so that's going to hang around. But it's going to be multiplied by 2x. Where in the world did I get 2x from? 2x comes from the derivative of that x squared power. Or excuse me, x squared being the exponent. So it's 5 times 2x times, don't forget, bring back your e to the original power, e to the x squared. All right? And so 5 times 2x gives us 10x e to the x squared. And that, folks, is our derivative. Okay? So the derivative of the exponent came out, multiply the 5, gave us 10x. And then we have, don't forget your e to the x squared. All right. Next example here. So this one's a little weird. This is we're used to the power changing. Remember, the power doesn't change on e. So if we have f of x equals e to the 1x power, then what is it? What's the derivative? Well, f prime of x equals, well, what's the derivative of a 1x? The derivative of 1x is 1. And then it has to multiply e to that 1x power. Well, what's 1 times e to the x? It's e to the x. So the derivative of e to the x is e to the x. That is weird, right? But that's the case. That's the rule. That's why we call that a transcendental function. That's don't worry about that. But anyways, that's the derivative of e to the x. It's the same e to the x. All right. Just a few more here. Okay, so suppose we have f of x equals e to the x minus 12x plus 4. Okay, for this one, we're going to do just our sum and difference rule, meaning we're going to look at each individual term here, and then we're going to take the derivative. So here we go. F prime of x equals, well, the derivative of e to the x, for the reasons we just discussed before, is e to the x, or if you want to, you can write 1 e to the x, minus the derivative of 12x is 12, and the derivative of 4 is 4. Or excuse me, 0. Derivative of 4 is 0 because it's a constant. Okay. Last one. Now, this one I will say, if you haven't watched the chain rule video, now's a good time to go ahead and pause this video, and I would say go over to the chain rule video. But this e, the derivative of e, can also be used within a chain rule. Okay. So let's say we wanted to find the derivative of e to the x minus 7 to the third power. Okay. So as I said, y'all, this may be a little confusing if you have not seen the chain rule. So maybe after you watch the chain rule, come back to the end of this video and this will make more sense. But what we do here is we take that power of 3. We're going to bring that out front. We're going to have e to the x minus 7. We leave the inside alone, but we raise it to the second power. And then we need to now take the derivative of just the inside, the e to the x minus 7. The derivative of e to the x minus 7 will be, well, the derivative of e to the x is e to the x, and the derivative of 7 is 0. So that is our derivative, 3 times e to the x minus 7 to the second power times e to the x. Or, if you want to get fancy, this 3, it can't distribute to the e to the x minus 7 because of orders of operations in that second power, but the 3 can multiply the e to the x. And so, kind of like a simplified way of writing it is 3e to the x, e to the x minus 7 to the second power. Okay. As I said, that one, if you have not seen the chain rule video, that one may be very confusing. Go watch the chain rule video and then come back to this example and hopefully it'll make more sense. Alrighty, folks. I'll see you guys in the next video.